Okay, this video is going to give an answer for this question. A falling rock has a height at time t seconds given by the function 100 minus 16 t squared feet. For example, the rock has a height of 84 feet after 1 second. We would like to estimate the velocity of the rock at t equals 1 second. In other words, v of 1 in v per second. To do this, first find the velocity from t equals 1 to t equals 2 seconds. Then find the velocity from t equals 1 to t equals 1.5 seconds. Do it again from 1 to 1.1 seconds. Continue in this fashion, give your best approximation to the velocity at the distance t equals 1 second. So, they give us the function of the rock's position. So I'm going to write that as f of t equals 100 minus 16 t squared. And what they want us to find is the velocity of t. And what I've learned in calculus class is that velocity is basically the position prime. So we're basically finding, we can establish that t of t equals f prime of t. And we're going to use we're going to use an interesting method for that. The method is that f of t is around the following equation. F of t minus f of a, we'll establish what a is in this circuit, all over t minus a. I cannot establish enough under the we have to establish here is that t cannot, I repeat, it cannot equal a. Because if t equals a and we look at the bottom fraction here, it'd be 0, and then the function would be undefined. They already give us f of t, f of 1. So we know that f of 1 is 4. So let's try it with when we're going to try this when a equals 2. At point t equals 2 seconds. So in order to do that, we have to go with f of 1 minus f of 2 all over 1 minus 2. And we already established that f of 1 is 84, and f of 2 is, so 16 times 4 equals 64. Subtract that from 100, and we get 36. 84 minus 36 all over 1 over 2. And 84 minus 36 equals 48 all over, and 1 minus 2 is negative 1. So it gives us the impression that we have negative 48. So that's for a equals 2. Let's try this again at 8. We're going to do this again for a equals 1.5. That's f of 1 minus f of 1.5 all over 1 minus 1.5. Like we established before. f of 1 is 84. Every 1.5 times 1.5 is 2.25 times 16 would be 36 minus 100 is, subtract that from 100 and we get 64. Subtract that on the bottom, so 1 times minus 1.5. So we leave that with the fraction 20 over negative 0.5. And with the reciprocals, dividing by a half is the same as multiplying by 2. So that's 20 times negative 2, which gives us negative 40. Now we're getting closer. Next, we're going to do this with a equals 1.1. So we're going to do the same thing as before. So that's f of 1 minus f of 1.1 all over 1 minus 1.1. So, like we said before, f of 1 is 84. And 1.1 squared is 1.21. Multiply that by 16, we get 19.36. Subtract that from 100, and we get 80.64. And that's all over negative 0.1, or 1 minus 1.1, either way. So next, that leaves us left with, so 84 minus 80.64 equals 3.36, all over negative 0.1. Like again, we could divide by a tenth is the same as a tenth. So we're now left with negative 33.6. And lastly, for the heck of it, we're going to do the final one at the value a equals 0.9. Sorry, this is taking so long, I know. So so same process. F of 1 minus f of 0.9 over 1 minus 0.9. So like we established before, f minus 1 is 84. And 0.9 squared is 0.81. Multiply that by 16, we get 12.96. Subtract that from 100, we get 87.04 over 1 minus 0.9. So now we're left on the top, we have 84 minus 87.04, which is negative 3.04. And subtract that from 0.1. And now we can just do the reciprocal again, and we get negative 30.4. Now, we have two values where one is directly in between them, 1.1 and 0.9. So we can use this to establish what f prime of 1 is. All we can do is add these two up together. Negative 33.6 plus negative, you know what? Let's do this on paper, shall we? Oh, negative 33.6 plus negative 30.4 equals negative 64. Since it's two values, we're going to divide that by 2, and we have negative 32. So based on this, we can come to the following conclusion that f prime of 1 equals negative 32. And that's our answer. The ball is at a velocity of negative 32 feet a second as it's going downwards. So that's the answer, and I hope that covers things for you.